Today we're going to be talking about 5.6 half-angle identities. So the first question we might ask ourselves are, what are the half-angle identities, right? So we have three half-angle identities, and they are the cosine of a half angle. So we'll say a over 2, or we can say theta, and it is going to be plus or minus the square root of 1 plus cosine of A all over 2. Again, notice that the radical is both over the top and bottom, so it is if you are rewriting it as the radical of 1 plus cosine of A all over the radical of 2. So again, two different ways that we can approach this problem. Now, why it's a half angle is because notice the A is your angle, and what is half of A? A over 2. The other way that we could potentially see this written, I'll write it in purple, would be as if you're saying cosine of just a regular A, and then again, plus or minus. So when something is half and it gives us A, basically we're going to be doubling the A, and so we're going to get 2A. So we're actually going to derive this using our double angle identity. So again, two different ways that we could see it. They both mean exactly the same thing. So we have sine. So sine of our half angle will also be plus or minus. This time it's going to be 1 minus the cosine of A all over 2. And again, we could rewrite this as the radical of 1 minus cosine of A all over the radical of 2. Or we can think of it this way, sine of A, and then plus or minus. And then 1 minus the cosine of 2A all over 2. So notice that both the half angles for sine and cosine, you actually just need the cosine. All right, so last but not least is tangent. Now, I want you guys to remember that for our double angles, we had 3 different ways to write cosine. For our half angles, we only have one way. For sine, we only have one way. For tangent, we actually have 3 ways. So, and I'm going to show each of those ways. So again, it could be 1 minus cosine of A all over 1 plus cosine of A in the radical, again, plus or minus, or we will see it like this, sine of A divided by 1 plus cosine of A, or we'll see this, 1 minus cosine of A all over sine of A. And again, we might see these in purple. So we might see it as plus or minus, so tangent of A is equal to, and then all we're going to see is the 2A with the cosine. Sorry that it's really small. And this will be the double angle, and 1 plus cosine of 2A. And then over here be 1 minus the double angle divided by the other double angle of sine. So interesting enough, you can actually use all 3 half angles with only cosine. You actually don't need tangent for the tangent half angles. So let's see how we can derive these, shall we? So let's derive our half angle. So let's do cosine first. So we will derive the cosine of A over 2. Okay, so we want to start off with one of our identities. So I'm going to start off, I'll do it in purple. So I'm going to say that the cosine of 2A is equal to 2 cosine squared of A minus 1. So it's one way I can write it. Okay, and basically what I want to solve for is I want to solve for my single angle, right? Because A is half of 2A. Okay, so I'm going to add 1 to both sides. So I'm going to get cosine of 2A plus 1. is equal to cosine squared of a. And then I'm going to divide by 2, and I'm going to get cosine of 2a plus 1 all over 2. Do not cancel these 2's out. The 2 is with the cosine, so we got to keep it with the cosine. And then we are going to take the square root, and we have to remember when we take the square root, we have to put plus or minus, right? So again, the cosine of a is plus or minus, and we can switch the cosine of 2a plus 1 to make it be the 1 plus cosine of 2a, either one. So again, notice that the larger angle is always underneath the radical, right? So what's half of 2a? It's just plain old a. All right, let's go ahead and derive the half angle of sine. So sine's half angle, we are also going to derive it from the double angle of cosine. And the reason why we're using these identities is because if we actually try to use the double angle of sine, right, to sine of theta or a, let's change that to a. It makes it a little bit trickier. We'd have to, divide by 2 over cosine, and it can be a little bit more complicated. But so we want to kind of focus on when it's just a single a kind of by itself. But in reality, again, I wrote theta. Again, we could, in theory, solve our double angle of or use our double angle of sine to solve for a single angle of sine. But this is the, what's the word I'm looking for? This is the formula that the world acknowledges as the half angle identity, so to speak. Okay, so how do I go about doing this? Again, I'm going to subtract 1 to both sides, so cosine of 2a minus 1. Do not forget that negative 2. And then we are going to divide by a negative 2. And we have to remember that the negative can go in both the top and bottom. So, because if you remembered, the negative was not in the denominator. So this will actually be a negative cosine of 2a, and then a positive 1 all over 2, and equal to sine squared of a. And then again, we'll take our square root. So again, we have to make sure that we say plus or minus. And I'm going to flip these two numbers around, keeping the 1 positive and the double angle of cosine negative, and then all over 2. So again, this is the universal symbol or universal formula for the half angle of sine. All right, last but not least, we have our tangent. So let's see how we can derive our tangent. So tangent half angle is right here. Well, the first thing I remember is that we have a quotient identity. So this would be the same thing as saying the half angle of sine divided by the half angle of cosine. So the first thing I'm going to do is I'm going to take my sine, and so this would be plus or minus, and then this would be the 1 minus cosine of, and I'm going to rewrite it with the one that we started off with. So it'll be the 1 minus cosine of a. So we'll do that one. So cosine of a, and then all over 2. And again, I'm going to divide that by plus or minus. And then this will be 1 plus the cosine of a all over 2. Now the great thing is I can rewrite this as one giant fraction. So it'll just be the plus. And this will be 1 minus cosine of a all over 2. And I'm just going to write it like this, divided by 1 plus the cosine of a all over 2. All right, division is the same as multiplying by our reciprocal. So I'm going to flip my second fraction. So it becomes multiplication. So 2, and then 1 plus the cosine of A. Notice what cancels out? The 2's. So we are left with plus or minus, and it'll be 1 minus the cosine of A all over 1 plus the cosine of A. Okay, and again, we could have said, we could have used the other identity with putting a 2 in front of it. Okay, so the question is, how do we actually derive these other guys, right? Because why use a plus or minus and a radical if we don't actually have to? Well, if you think about it, we're going to be able to get rid of the radical, right, by rationalizing our denominator. Okay, so what does that kind of look like? So I'm going to start with what my half angle is. So tangent, right? And I'm going to write it this way, so that way we can kind of see it a little bit easier. So tan of A is going to be plus or minus, and I'm going to say 1 minus the cosine of 2A and 1 plus the cosine of 2A. And again, half of 2A is A, so this is, again, just another way to write it. I'm showing you different ways to write it so we can get familiar with it. So what I want to do is I'm going to rationalize kind of almost like rationalizing my denominator. But in order to kind of get rid of my radical, I need to have perfect square, I have to be able to take the square root of something. So what I'm going to do is I'm going to multiply the top and bottom by a fraction of 1. And again, I can do that because it doesn't change my answer. And when I do that, again, I get plus or minus, my two binomials, right, stay the same. So this will become 1 minus cosine of 2A, and this will be squared. I'm not going to go ahead and multiply that in. 2, sorry. The bottom, right, is going to be I can multiply these together. It's a difference of 2 squares. So it's going to become a 1 minus cosine squared of, let me rewrite that, of 2A. And again, there's a radical over both, okay? Well, the cosine squared of 2A, right, should kind of remind you of the Pythagorean identity, right? So sine squared of A, right, plus cosine squared of A is equal to 1. So I can change this to a double angle if I wanted to, as long as it's the same for both, right? So I can say that the cosine squared of A, or 1 minus cosine squared of A, is or 2A, sorry, is equal to sine squared of 2A. So I can go ahead and I can replace the numerator or the denominator with that. And while I'm at it, I'm going to rewrite this problem so that my numerator has its own radical, and then my denominator can have its own radical. Well, the great thing about the numerator is the radical sign and the squared sign go away, so 1 minus cosine of 2A, and in the denominator, the same thing will happen. The squared and the squared will go away, and you're just left with sine of 2A. And again, this is equal to the tangent of A. Notice what is half of 2A? A. So we could also have written this tan of A over 2 and then 1 minus just cosine of A sine of A. So we would do the same thing to derive the other one. The only difference is instead of multiplying it by 1 minus, it would be 1 plus. Okay. All right. So so what can I do? How can I find what can I use with my half angles, so to speak? Okay. I can start to find other values for my half angle, right? So for instance, if I want to find the cosine of 15 degrees. Now, we already found the cosine of 15 degrees one way using our sum and difference of cosine. But what happens if we didn't want to use that value? What we can do is we can use our half angle. So how I would use my half angle, right, is I would say that the cosine of 15 degrees is equal to plus or minus the radical of 1 plus cosine of 30 degrees all over 2. Now, how do we decide about plus or minus? Well, 15 degrees is in quadrant number 1, so that must mean that this is going to be a positive number. So 1 plus cosine of 30 degrees. You are not going off of the 30 degrees. Okay, you're going off of what are you finding? Okay, so now what we can do is we can replace what we know. So I'm going to replace my cosine of 30 as the root 3 over 2. All of that is being divided by 2. Take the square root. So again, this is just another way we can find this. Make them be the same denominator in the top. So this will be 2 plus root 3 all over 2. And I'm going to say divided by 2. Again, put it all underneath one radical. And so division is the same as multiplying by the reciprocal. So divided by 2. So this will be 1/2, and again, over a radical. Multiply the numerators together, so 2 plus root 3. Multiply the denominators together, we get a 4. We can separate the, actually I'll bring it up over here. We can separate the numerator and the denominator. So we would get the radical of 2 plus the square root of 3 all over 2. And so this is what the cosine of 15 degrees is, using the half angle. So again, using half angle to find it. So again, just another thing that we can do. Okay, so let's go ahead and use these identities to write write our expression as a single trig. So what does that mean? So here's our next direction. So use the identity to write each expression as a single trig. So here's our first problem. I'm going to say that this is the square root of 1 minus the cosine of 50 degrees divided by 2. Okay, so when I see this, right, what I'm thinking, let's change colors, is that this, right, is my double angle. Okay, so I know that I want to take half of 50. So I'm going to take half of 50. So I'm going to get 25 degrees. And then I have to ask myself, which one of the 3 half angle identities does this look like? So if I go back to this slide, right, which one has a 1 minus? And that would be your sine. So your sine has the 1 minus. So this would be the same thing as saying sine of 50 over 2, which is the same thing as the sine of 25 degrees. Now, we don't know what the sine of 25 degrees is, so we cannot simplify this problem anymore. All right, let's try another one. What happens if I have something generic like this? 1 plus cosine of 20x all over 2. So again, I see that it's a plus instead, so this would be the same thing as saying the cosine, and again, what's my angle? 20x all over 2. It's okay that we don't know what x is. Let's leave it alone. And then this will just be the cosine of 10x. And again, that's all we can do, which is okay. All right, so let's get into some more challenging questions, right? So here's our next question. This one's a little harder to pre-write. So we are going to find the cosine of theta over 2. So I'm going to change it back to theta, given this information. So given that the sine of theta is equal to a negative 1/2, and theta is within 180 degrees and 270. So that's our given information. So given information. All right. So I have a lot of things to kind of unpack. So the first thing I have to unpack is what is the half angle of cosine? So again, half angle of cosine is plus or minus, and then this will be 1 plus cosine of theta all over 2. Okay, so that's the first thing that I have to figure out. Okay, so I have to find the cosine of theta. So I'm just going to make a list of what I have to find. So I have to find the cosine of theta. The next thing I should also find is what quadrant is theta over 2 in, right? And then once I do that, it seems like that'll take away my plus or minus. Finding the cosine of theta will take away that value. So then I just have to simplify. So simplify fraction. Those are my 3 things that I have to do. Okay, so the first thing seems logical. Let's find the cosine of theta. So, how do we find the cosine of theta? So we're going to use this information. Okay, so I know that sine is made up of y over r. So in order to find the cosine, I'm going to, again, use x squared plus y squared is equal to r squared. So x squared plus negative 1 squared is equal to 5 squared. So 25. So x squared is 24. Take the square root of 24. Simplify the square root, please. So it gets broken down into 4 times root, or 4 root 4 times root 6. So this would be plus or minus 2 root 6. So the first thing I need to do is find the cosine of theta. Now, this is the third quadrant. So cosine is negative in the third quadrant. So this will be a negative 2 root 6 all over 5. All right, so that was the first thing I have to do. Second thing I have to do is I have to figure out my quadrant for my half angle. Okay, so that's the next thing I'm going to do. Okay, so what we're going to do in order to find our quadrant for number 2 is we are going to take the information given to us here. So I have 180 degrees, theta, and 270. So what I'm going to do is I need this theta to become the half angle. So let's just divide it by 2, which means I'm going to divide 180 by 2, and I will divide 270 by 2. When I do that, I will get 90 degrees here, theta over 2, and then I will get 135 degrees. So this means, this is for my half angle. I'm between 90 and 130. That means I'm in quadrant 2. All right, so once we find quadrant 2, I have figured out my first thing I needed to find. I figured out my second thing. So now I just need to plug in and solve for this. So I'm going to say the half angle of theta over 2, so of cosine, is in quadrant 2, so this is a negative fraction. And then I'm going to say 1 plus a negative 2 root 6 all over 5 and divide that by 2. All right, so I can simplify my fraction. So this will become a 5 minus 2 root 6 all over 5. Multiply that by a half. Again, this is a negative radical. And the reason why I'm multiplying by half, because originally I was dividing by 2, so I'm multiplying by the reciprocal. So then this will become a negative radical of 5 minus 2 root 6 all over 10. Now, the radical we don't need to separate to the numerator and denominator because 5 minus 2 root 6 cannot be simplified, and neither can the 10. Can't take the square root of it. So that means you are done. All right, let's try another one. One more kind of similar to this. All right, so this time, let's find theta over 2. And the given information will be that cosine of theta is equal to 2 over 3. And we are told that it's 3 pi over 2 and to 2 pi. So that is our given information. And again, if you want to pause the video and try this one on your own, you can. All right, so again, I'm going to write out my identity. So theta over 2 is equal to plus or minus, and this time it'll be 1 minus the cosine of theta all over 2. All right, so first thing I need to do is make my list of what do I need to find. Well, just like before we had to find the cosine of theta, well, this time I already know the cosine of theta, so I guess I don't have to worry about that. So that's great. The second thing I need to figure out is what quadrant, is our half angle in? So that's a good question mark. And then we are going to plug in and simplify. Okay, so let's go ahead and find our quadrant that we're in. So I'm going to take my 3 pi over 2 theta and 2 pi, and I'm going to go ahead and I'm going to divide everything by 2. So divide by 2, divide by 2, divide also that by 2. So this will become 3 pi over 4 theta over 2, and that's purely just pi. Okay, so 3 pi over 4 is 135 degrees, and then pi is 180, so we know that we're in quadrant number 2. Okay, we're towards the end of quadrant number 2, whereas we originally started, we were in quadrant number 4. Okay, so we're in quadrant number 2. Important information, boom. So that means that sine is positive in quadrant number 2. So when I simplify this, so sine of my unknown angle, who knows what it is, so this will just be a positive. So this will become 1 minus, and then just 2 over 3 divided by 2. So let's go ahead and simplify this. So this will become 3 minus 2 all over 3. Again, multiply top and bottom by 3. And I'm going to multiply that by 1/2. Again, divisions is multiplying by the reciprocal. So I'm going to get 1/3 times a half. Take the radical. So this will be the radical of 1 over 6. Now we can actually simplify this a little bit more since it doesn't have a binomial. So this becomes the radical of 1 over the radical of 6. You can kind of skip that step. And you can just say 1 over root 6. So multiply top and bottom by root 6. So we will get root 6 over 6 as our half angle of sine. And that's our answer. Right, and that is all we have to do for half angles.